Okay, so in this section, we will introduce how to solve the exponential and the logarithm equations. Okay, so most of these examples are from your homework. Okay, I selected from your homework. Okay, so start with first one. 16x equal to what? 128. Okay, so what will be the should we do first? Okay, so if you have this, of course, if you can find the same base, that would be awesome, yeah? So 16 is what? Could we factor 16? It's 2 to the what? 4th. Okay, so if you do not know how to do this, you 16. So 16 is equal to what? 4 times 4. 4 is what? 2, 2, 2, 2. So how many 2's do you multiply? 2 to the 4. Okay. So 128. Similarly, you can do, 128 is 264, 8, 8, 4, 2, 2, 2, 4, 2, 2, 2. Yeah, wow. This is a lot of 2's, yeah. So it's 2 to the what? 7. So what do we have for this question? It's 2 to the 4 to the power of x equal to what? 2 to the 7. So what should we do from here? Is 2 to the 4x equal to what? 2 to the 7. Yeah. So because power to the power you multiply, okay? So what do we have? 4x equal to 7 and x equal to what? 7 over 4. X equal to what? 7 over 4, which is the answer, okay? Similarly, so 3 to the x minus 6. Okay, so 243. Okay, so 243, 381, 99333. Yeah, are you with me? So it's 3 to the 5th. So do you remember what means 1 over? Means 3 to the negative power. So what do we have? X minus 6 equal to 5, and x which will be 11. Okay, so this one, so for the first and second example, you do have the same base. You can create the same base. But for the third and fourth example, 2 and 17, could you create the same base? No. E and 336, could you make the same base? Then what should we do? How could we find the exponent? Okay, so maybe somebody can remember. So if you wanted to isolate an exponent, what should we do? Okay, we write this in the exponential form. Means what is the corresponding exponential form? We keep the same base 2. Okay, so x used to be on the same side with 2, so now it's on this side. 17 on different sides, now it's the same size. So x equal log to 17. How could we find this value? And we have changed our base formula, yeah? So it's ln of 17 over ln of 2. Ln of 17 over ln of 2. Okay, so what will be ln of 17 over ln of 2? Is, you can use your calculator, it's 4.09. Okay, so what should we do for this one? Okay, so it will be what? On the other side, yeah, log e keep the same base, 306, 6 minus 3x, yeah? So what do you have? 6 minus 3x equal to ln 306. Then what will you do? You solve this. So it's 3x equal to ln 306 minus 6. X equal to what? Ln 306 minus 6 over 3. What is the common error? So many students will be 306 minus 6 is 300. No. you cannot combine these two parts together, okay? Just leave it alone, okay? Leave it alone, okay? Very important. So because G306 belongs to logarithm, it's not a separate number. Okay, so the next type is a little bit complicated. So you have a 7 and you have a 5. Okay, you cannot make the same base. And what is the worst? On the exponent, you both have what? Variables. So what should we do for this kind of questions? We have to apply natural log on both sides. Okay, you can also use the common log, but natural log, looks nicer, so it's only have 2 letters, yeah. Okay, so then what should we do? Why do we want to do this? Because from the properties of logarithm, we know that the exponent can be what? Moved to the front. So what do we have? 4x plus 1 ln 7 equal to what? X plus 1 ln 5. So you can move it to the front, yeah? Are you with me? So then what do we need to do? Distribute, yeah? So you have 4 ln 7x, yeah? Plus ln 7, you have what? Ln 5 times x plus what? Ln 5. You with me? So 4 ln 7 ln 5, do not be frightened about this number. They're just, a number. Are you with me? So this is the same as 3x, 2x. How could you solve this? Combine like terms. So what do you have? 4 ln 7 minus what? Ln 5x. You subtract. And then what will you do? You subtract ln 7 on both sides. You have ln 5 minus what? Ln 7. So what will be the x? Equal to what? Ln 5 minus what? Ln 7 over 4 ln 7 minus what? Ln 5. Okay, so it's pretty easy. It just looks a little bit weird, and a lot of students will be confused. Oh, it's so hard, but no. So these are only some big numbers. Okay. So the next part we want you to solve is what? Logarithm equation. So the first 2 examples, logarithm this. Okay, so we want to find x, yeah? How could we do that? Want to isolate here. Where is the x? X belongs here, yeah? Isolate. What should we do? Exponential form. 7 squared x plus 5, yeah? So what will you have? X equal to 49 minus 5 is what? 44. But for logarithm functions, you need to what? Check. So what means do you need to check? Is the domain is x plus 5 has to be what? Bigger than 0. Is 44 plus 5, 49, bigger than 0. Then what happens? It's okay. Okay, so for this one, what should we do to do this one? If you have extra 2, what will you do? Okay, divide it. It's ln 4x equal to what? 5. Okay, so what should we have here? 4x equal to what? E to the 5. And x equal to what? E to the 5 over 4. Do not forget to check. It's 4x equal to 4 times e to the 5 over 4 is equal to e to the 5, which will be what? Positive. So, perfect. Yeah, so the next question is we not only have one logarithm, we have a couple. What should we do? Combine them into one, yeah? So what do we have? Log. Addition means multiplication, x times x plus 2. Log what? 3. Same base, yeah? Same base here. What happens here? It's x plus 2 equal to what? 3. So how could we solve this? X squared plus 2x minus 3 equal to 0. So what should we do? Negative 3, we wanted the 3, negative 1, so because add to be the positive 2. x plus 3, x minus 1 equal to 0. So what do we have? X plus 3 equal to 0 or x minus 1 equal to 0. So x equal to -3 or x equal to 1. Are we done? No. You have to check. Make sure it is in the domain. For x equal to -3 and x plus 2 is -3 plus 2 is -1. So less than 0, what happens here? Not good, yeah? Not good, because we wanted it to be what? Bigger than 0. You with me? Okay, so the second question, equation, x equal to 1. So the domain x equal to 1, bigger than 0. X plus 2 is 3, also bigger than 0. Both, it has to satisfy both. So x equal to 1 is okay. So x equal to 1 is the solution here. Are you guys okay? So when you check your solution, you have to check the domain of both one. Okay, so if it only works for one of them, it's not in the domain either. So it has to satisfy both. Okay, be very careful. Okay, so let's review. So if you have 2x equal to 17, this one equal to 306. If you cannot make the same base, what will you do? Change to logarithm. And so 7 and 2, e and 10, you cannot make the same base. Change to what? Logarithm. Okay, and for the exponential, this one is a little bit complicated, and this one is also one. Okay, but you always, for the logarithm function equations, you always need to check whether your solution is in the domain. That's very important. Okay, so then we wanted to work on one question is the application question. The formula A equal to this models the population of Tennessee in millions 10 years after 2000. So what will be the population in 2000? 10 years after 2000, yeah? So at 2000, what happens? What does this mean? So T is 10 years after 2000. At 2000, part A, at 2000, your T equal to what? 0, not 2000. Are you with me? Because this is 10 years after 2000. And 2000 is 0 years after this. So what will be A? It's 24.2. E to the anything times 0 is 0. E to the 0 is what? 1. So it's 24.2 million. Okay, so the second question is, when will be the population reach 31.4 million? So this means A equal to 31.4, yeah? So this is the population. So is what? A equal to 24.2, E to the 0.07760. So it's 31.4 equal to what? 24.2 e to the 0.07660. What should we do? We wanted to divide, yeah? So isolate 24.2 equal to e to the 0.07660. Then how could we isolate this one again? We rewrite it into what? Logarithm form. It's 0.0766t equal to what? Ln 31.4 over 24.2. So what will be t? Is what? Ln 31.4 24.2 0.0766. Okay, so what will you do? You plug these things into your calculator. What will you get? Maybe around 3. So which year is 2000 plus 3? It will be what? 2003. You will miss you will reach 31.4 million. Okay, so this is the application question, and that's